Yes.
Okay, thank you. So yesterday we tried to cover what are the elements in GAMS. So we have seen that data that is in form of tables, sets, parameters, and scalar. So our model that is consisting of data and then in decision variables that we have seen that is in form of continuous variable that we have seen yesterday. So as per the problem, it may be integer, it may be a binary variable of 0, 1 case, that is special class of that integer variable, and semi-continuous variable as well. And this some of the variables that we define in some within the range, that is SOS. So we have constraints. Constraints are the features that we have seen for the models. So that is constraints and then model. We have this for model types of linear programming, mixed constraint programming, mixed integer programming, non-linear programming, quadratic constraint programming, and MINLP, mixed integer non-linear programming. So we implement that is in GAMS and we will get the kind of output that we would like to get. Okay, so on the basis of this nature of this GAMS element, we have the model type. So in linear programming that we have implemented 2 models yesterday. So the variables of the continuous nature. So if you go to this file and check in the day, or not day 2. Okay. So we have seen our decision variable, which is x11, x12, x13, or in generalized form, this is xij. It is the amount of to be transported from supply locations I to delivery locations j, which was continuous because it can take any value. It can take any fractional value or as well the a discrete value. So it was a continuous in nature. So that is why in linear optimal linear programming problems, our variables would be continuous. There is no discrete variables in our linear programming. So if there are discrete variables, it will become integer linear programming or mixed integer linear programming, if we say. And the objective function, that should be linear as well. So in our problem that we have implemented yesterday, we have seen this. This was our objective function. We were multiplying Cij and that was the cost parameter to Xij. So it was linear. So it was linear in nature as well as it continuous in nature. So that was linear. So and the constraints, all the constraints that we have seen. So we have a couple of constraints for the supply and the demand, both were linear. So all of these things are linear, so that is why it was linear in nature. So in non-linear programming, our variables can be continuous and objective functions can be linear as well as non-linear, and the constraints can have the same nature of linear and non-linear. So when we try to introduce discrete variables in our model, so it could be our mixed integer linear programming or mixed integer non-linear programming. So when we will have this non-linearity of either in the form of constraints and objective function, as well as the discrete variables and continuous variable, it will become mixed integer non-linear programming. Why it is important? Because there is a nature of that problems model that you can solve with some kind of solvers that we have given. So we will try to study linear programming today, and we will try to cover non-linear programming, integer linear programming, and some sensitivity analysis later on. Okay, so linear programming is an optimization method which is applicable for the solution of problem with the objective function and constraint which are in linear form and linear functions of decision variables that we can say. So the constraint equations in a linear program that may be form of equalities or inequalities. So yesterday that we have seen that these are inequalities because the supply should be less than equals to whatever production capacity of those plants, and then demand that should be demand, that supply should be whatever supply that we have, that could be higher than whatever the demand at the market locations. So it was inequality. So it can be inequality as well. So the constraints. So it is first recognized in 1930 by some economists for developing optimal allocation of resources. During World War II, that's US Air Force sought more effective procedures to allocating resources, and there was one economist, we can say mathematician, George Danzig, who applied this linear programming problem, and they have implemented simplex algorithm to solve this linear programming problem. So till now, at least 4 Nobel Prizes were awarded for the contribution related to linear programming. And in 1975, for instance, in 1975 by the L.V. Kontovich from the Soviet Union, and T.C. Kopmans for the United States. And there are some other methods to solve linear programming apart from the simplex method. But it is one of the most effective method as of today as well to solve the linear programming problems. There are some other methods of Karmakar method. It has been developed recently, we can say in 1984, and it has shown up to be 50 times faster as a simplex algorithm. But it is applicable in some of the problems, and some of the problems we have to move towards a simplex algorithm only. So there are some applications that we have seen, and linear programming has applications in each and every area, whether it's economics, whether it's hospitality, whether it's hospital administration, everywhere we have seen these examples of these applications. So we try to cover that transportation problem, and then we will try to cover that crop problem, and we will go through the diet problem today, and obviously CGE models, all of most of the models that we study in this course later on will be of linear programming problem. Okay, so it is a standard form of linear programming problem. We have objective function, which is in the form of minimization, and this we have seen it yesterday as well, which is C1 x1 C1 plus C2 x2 plus up to Cn xn, which is basically we were minimizing cost multiplied with the decision variables that we have seen. Okay, so this was Cij multiplied with Xij, and which is sum over I and j. So our objective function, so of minimization type. So this. So we were minimizing cost. So this is one of the standard form of objective function in a linear programming problem.